Shit. So yes, I will show you what is the method for displaying this. So for that, I'll go to command prompt. I have shown you a class for integer, so I will visit the same class java.lang.integer. Okay, so this class is having one of the interesting method. Let me scroll up and show you. This is a method you see. Two hexa string or two octal string or two binary string. So two binary string will convert an integer into a binary form, and that form will be given in the form of a string. So binary bits of an integer are given in the form of a string. That's what we want. We want to see how it looks like in the form of binary inside the memory. So I will directly print here. I will say system.out.println. Now I will call this method integer dot to binary string is the method. Now which number I want to do? X. So that's it. So this is going to show a binary form of that X. Let us save and run it. JavaC data data type details. Yes. Compile it. Yes, it is showing the binary form of a number that is 101. Though it is integer, it is having 32 bits, but the leading bits are 0, so that is the reason it is not showing. This I have shown you on one. Code, right? So I will take it as -5. Now see how this -5 is stored in two's complement form. So the value that I have shown you on whiteboard, the same value will be able to see here. Let us save, compile, run. Yes. See, this is the integer. I have taken one byte on whiteboard, so I have shown you only 8 bits. But this is having 32 bits. Integer takes 4 bytes, so all 32 bits, all these bits are 1, and last 4 bits, if you see, 0, 1, 1 are given. Right? So this is stored in two's complement form. So that's it. This is what I wanted to show you, and so now you are sure that it is stored in whose complement form and how the whose complement looks like. So that's it. So this method, that is true binary string, is present only inside the integer class. It's not present in any other data type. So we cannot get the binary form of every data type. It was possible for integer, so I have shown it here. If you want to do it for byte and short, you have to convert it to integer and you have to use the same one. But for float data type, there is no method available like this for converting it into a binary string. So that's all in this video. The purpose of this video was just to pattern looks like. For floor numbers, I will just give you the basic idea behind how the floor. So you can move in this direction also, both options are there. So let us move it in that direction. So let us make it as 16352, and then சொல்லுமா.
சாப்பிட்டியா?
ஆமா,
போய் வாங்கிட்டு வந்து சாப்பிட்டியா என்ன பண்ண?
வாங்கிட்டு வந்து சாப்பிட்டேன். அப்புறம் ஒரு மாங்காய் இருந்துச்சு, அதை கட் பண்ணி சாப்பிட்டேன்.
காய் தானே இருந்துச்சு, பழனி இல்லையே, அதே என்ன
இல்ல 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 பழம் இருந்துச்சு ஒண்ணு, அழுகுற மாதிரி இருந்துச்சு, அதை எடுத்து சாப்பிட்டேன்.
சரி, பழம் அந்த இதுக்குள்ள சாப்பிட்டியா? மாதுளை பழம் சாப்பிட்டியா?
மாதுளை சாப்பிட்டேன். அப்புறமா நீங்க கொடுத்த நட்ஸ் சாப்பிட்டேன். அப்புறமா வந்து தாத்தா கீழ இருந்து வந்து பப்பாயா கொடுத்தாரு, அது சாப்பிட்டேன். எல்லாம் ஃப்ரூட்ஸ் தானே.
சரி, அப்ப ஈவினிங் என்ன சாப்பிடுவ? அது கொஞ்சம் வச்சிருந்துருக்கலாம்ல, பப்பாயா வச்சிருந்துருக்கலாம்ல.
சரி விடுங்க, நீங்க பப்ஸ் வாங்கிட்டு வந்துருவீங்க, விடுங்க.
நாளை வாங்கிட்டு வந்தாங்களே, நோ பப்ஸ். சரி, இப்ப துணியா வந்துட்டு கேப்பா?
இல்ல ஒன்றரை
கொஞ்சம் வந்துருப்பா. காயம் நல்லா கொஞ்சம் தான் இருக்கும், ஒரே ஒரு பக்கெட் தான் வரும். சரி, decimal point. So this decimal point has moved here, means when this decimal point will move there, if you multiply the number by 100. So I'll bring back the point here and I will say I'm multiplying it by 100. So then divide it by 100 also. This becomes 1. So multiplying and dividing the number by So this becomes 16352. When you multiply it by 100, this decimal moves out. And then this is 1 by 100. So this is 16352 into 10 to the power after the last non-zero. So this is how numbers are represented. But they represent a decimal number. This is how they represent decimal number. And this representation, this portion is called as mantissa, and this portion is called as exponent. right? An exponent is always 10 to the power. So this is understood. It is 10. So this is also written as 16352 e minus 2. So e means 10 to the power of minus 2. So this is how numbers are represented, decimal number. So this is also called as a scientific representation. So this is just a basic idea I have given you how floating point numbers are stored. Actually, it is stored in binary form. So there is a procedure for conversion of this one. So if you want, you can study it, you can explore it, right? So as a programmer, you should have little idea about this one. So it is represented in the form of mantis and exponent. This is important. Now, next thing, float takes 4 bytes, and the method of representation is actually made as a standard, and that is IEEE standard, and that standard number is 754. If you know this also, it's better. Every electronic device follows the same standard, so it is standardized internationally. So this is a standard followed by every electronic device, and they all follow that method. So this is just the idea about that method. Now next thing about double. So why we have a double? So if you want more precise value in decimal point, then you can go for double. Means after decimal, if you want a number 12.539462. So 1, 2, 3, 4, 5, 6, up to 6 digit float is suitable. If you have more number of digits, then you can go for double. So after decimal point, if you want more precise value, more detailed value, then you can go for double. So most of the times we compromise with just 2 digit after decimal or 3 digit we may take, right? We stop there. But some cases, every digit is important after decimal. So if you have more and more digits, so that is more accurate value, it is treated as accurate value or precise value. So if you want more values after decimal point, go for double. So this may support up to 6 to 7 digits after decimal, and this may support up to 14 to 15 digits after decimal. So this is all about floating point data type. Now let us come to character. Characters, like in English language, we have alphabets like A, B, C, so on to Z, or we have lower cases A, B, C, and so on to Z. These are alphabets. So basically, computer doesn't support alphabets. Then we use numeric values instead of these characters. So those numeric codes for English alphabets are called as ASCII or ASCII, American Standard Code for Information Interchange. So these ASCII codes are there for uppercase English alphabets, lowercase English alphabets, and digits, numeric digits also. And for other special characters, anything that you find on the keyboard, for everything there is a ASCII code available, all the special characters. So this is common thing. This is supported by other languages also like C and C++. But in the internet, as it is connecting people globally with various languages, so internet supports multiple languages. So programming language should also support multiple languages. So there are codes defined for all natural languages, various natural languages like English, Hindi, Bengali, Marathi, German, Spanish. For various languages, codes are there. So those codes are called as Unicodes. Unicode. And these are also standardized. Every programming language supports Unicodes, the latest language supports Unicodes, and they follow same codes. So these ASCII codes actually becomes a part of Unicode. Like for all other languages, we have a Unicode. So in this, English is also one of the language. So if you want to study what are the codes for your natural language, right, it's like your mother tongue, then you can go to unicode.org and find out the codes for that one. So there is a chart available, charts are available, so you can search for your language and you can find out the codes and you can use those codes. Now let us see what are the codes. See, for English language, capital A is 65, numeric value 65, and this is capital Z is 90. So it means 65, 66, so on to 90. And for lower cases, 98, 122. And for this 0 or so on, this is 48 and this is 49 to this is 57. See, these are symbols, right? Symbols, and these are codes for those symbols. That is not a number. Don't call it as a number 9. as a symbol 9, and its code is there. Like this is symbol Z and its code is 90. Same way, symbol 9, its code is 57. So these are the codes, and the ASCII codes actually range from 0 to 127. This is the range for all other special characters included that are within 127. So for the largest value 127, only 7 bits are sufficient. So ASCII codes are only in 7 bits. But when we talk about supporting various natural languages, 7 bits are not sufficient. We need more spaces, right? So that is the reason Java takes 2 bytes for a character to support Unicode. And that too, it takes the numbers that are positive numbers only, 0 to 65535. So only positive numbers it allowed, because there is no use of negative numbers in terms of characters. So this is about character data type. And the last thing is Boolean. So this Boolean data type allows only true or false. For storing true or false, only one bit is sufficient, right? If this bit is 0, we can say positive, and if it is 1, we can say negative. This is possible. But in Java, how many bits it takes, it's not defined. It depends on the runtime. That depends on the JVM. And Java allows only 2 values, that are true and false. That's all. So that's all. This is about data types. So I have gone into detail. I have shown you how negative numbers are stored, why we have 4 types of integral values, and how floats are stored. So this is the extra things that we have learned in greater detail that are helpful for utilizing these data types efficiently, and also for answering job interview questions. So the next video I will talk about variables. In this video, I will show you Unicodes, and also I will write a simple Java program for displaying characters of different ORG. Yes, this is the website. Now if you scroll down a little bit, here you will find code charts. So here the charts for all various languages are available. Let us click on this one. So here you can see languages. So I'll select one of the language here. Greek language is there. I'll click on this one. This is the Unicode chart for
charts. So here the charts for all various languages are available. Let us click on this one. So here you can see languages. So I'll select one of the language. Here, Greek language is there. I'll click on this one. This is the Unicode chart for Greek language. You can see that the Unicodes for Greek language are starting from 0370 onwards. 0370. This letter is 0371. This is 0372. Four-digit letters. Actually, these are hexadecimal codes. The numeric values are in hexadecimal codes. So it is starting from 03C8. Let us run it. Yes, I got that symbol. Here I got the symbol. So this is how you can find out Unicodes and you can display them. Now, I will write down the code for printing all the symbols of a Greek language. Let us do it. So for this, I will use this println inside a follow character type variable C, starting from hexadecimal 0370 onwards and x is less than or equal to 03FF, and every time, sorry, this is not x, this is C, and C++ go on incrementing the character. Now here I will print C, and between every alphabet I want some space, so give some space. And I will remove ln, so it will just print the letters. I will remove this character also. Okay, now, yes, here I have to write 0x03ff. Now this is perfect. So we have not learned about for loops yet, but I am using it just I want to display all the letters of that Greek alphabets. Let us run now. Yes, I got all the alphabets here. Letters from Greek language. You can see that. 1, 2, 3, 4, 5, 6, 7, 8. Then after that boxes are there. Okay, then comma, like symbol, then so on. So let us go back to the chart. Just keep remember these symbols. 1, 2, 3, 4, 5, 6, 7, 8. Then after that boxes are there. Means for these alphabets are not there. So that's why we got boxes there. Blanks are there. So we got boxes. So that's all about Greek language. I'll take one more language, Indian language, and I will show you the alphabet. This is also called as Devanagari language.
In this video, I will show you how to download, showing the details of a Java folder, Notepad, but it is better than Notepad because it is supporting some color codes for the keywords and other things in a language. Line numbers are also given here, and it is an editor for writing programs. Okay, so this is better than Java. So if you prefer writing the program and compiling and executing at command prompt, then you can go for this Notepad++. All right, so it's your choice. I may be using NetBeans in my course, right? At most of the places, I will be using NetBeans. In the beginning, I am using Notepad. Later on, I will be using NetBeans. So that's all in this video. Follow these steps. These are all simple steps. In this video, we will download and install. So it has automatically detected the path. So how it has detected the path? Because it found that in the path variable, see, Java SE13 is selected here. These are all simple steps. All right. In this video, with anyway for learning purpose, the community version is sufficient. Brains. So if there are any issues, they will. This is no JDK developing command and application. Now it is executed. Here at the bottom in the output window, you can find it by yourself. So that's all in this video.